Hi everyone. Thank you for joining us for Best Practices for Securing Your Serverless Applications. My name is Rob. I'm a Senior Developer Advocate on the Serverless team here at AWS. Today, you're going to learn how serverless application security is different from traditional application security, different factors that you need to consider. You're also going to learn some similarities. What tools and practices can you carry forward from traditional application experience to use when building your serverless applications? We're going to offer you some specific service-specific security guidance so that you know what to apply to each service when creating your applications. And finally, we're going to give you a little bit of advice on considering trade-offs, how to begin to apply these rules to your specific use cases. So let's start with the differences. Here, you'll see the AWS Shared Responsibility model. You may already be familiar with this model as it delineates the differences between what AWS is responsible for, or security of the cloud, and what you as the customer are responsible for, or security in the cloud. However, this diagram is specific to serverless applications, and there's a portion of this diagram that you see that we take responsibility for when you begin to build your applications using a serverless model. These are areas of responsibility that we assume, or in other words, these are areas that we secure for you. When you begin building with a serverless model, you can take the effort that you are putting into your application in these areas and begin applying it to creating features that add value for your customers. This allows you to create customer value faster and deliver more features for your customers. Another major difference of developing serverless applications is finer-grained control over your security. In a traditional application, every line of code that you have is exposed to every resource that your program or application can access. That's represented here on these three axes. The first is complexity, and you can't really do much about that with your application. There's a certain amount of real-world complexity that you'll face. When you consider that across your entire application, it's present all at once. The problem with this is that complexity is where bugs and security holes can creep into your code. So it's a risk axis for you. On another axis, we see resources. Resources are things such as data stores, object storage, APIs, secrets, anything that your application needs to access. When you're running a traditional monolithic application, the application has access to all of those resources all the time, both reading from and writing to them. The third axis that we have here is dependencies. In modern application development, you probably won't write every single line of code for your application yourself. You'll rely on first or third-party dependencies to solve known problems. However, any use of a dependency introduces a risk. In a monolithic application, any risk introduced by one dependency has the potential to access any resource used by any other component of the application. There's a formula here on the slide, but it basically shows you that complexity and risk grows cubically in a monolithic application. With serverless, each function has its own dependencies, its own resources, and its own reduced complexity. This offers several benefits. First, a reduced complexity means you have a smaller mental model to consider, and developers are much more likely to hold the correct model of the portion of code they're working with in their head at any given time. You also have access to fewer resources. For example, your customer writer function could only have access to write to your customer database. It wouldn't have access to read or to access any other database at all. Finally, you would use fewer dependencies in each function. Each function only needs the dependencies to perform its core business logic. And this means that while the model for each function and the model for the monolith each have axes, adding to any one of those axes only creates a linear increase in risk for your function because it doesn't increase risk across unaffected functions. If all that sounds a little bit hand-wavy, in plain language, we're saying that the risk of a serverless application is much lower, but it's still present. And that's one of the first similarities that we talk about when building serverless applications. Security is not free with serverless applications. It still takes work, and that work is up to you. You need to secure your application layer, ensure that your logic is correct, or that you don't provide additional permissions for users beyond their roles and responsibilities. That also means you still need to manage authentication and authorization. You need to make sure that your data is encrypted and stored securely, both in transit and at rest. And you need to ensure that you're monitoring your application for unexpected usage, as well as logging to see any unexpected behavior. Now, there is an existing framework that you can use to evaluate your serverless application, and that's the OWASP Serverless Top 10. You'll see a link to the OWASP Top 10 here on the slide, and it prevents 10 domains for you to focus on when developing serverless applications. We're going to use these domains and the language from the OWASP Top 10 through the next slides in this section. The first area that we said you'd have responsibility for, or retain responsibility for, is application layer security. Every user's application has different use cases and risk tolerance. AWS enables you to build your applications according to your needs. What this means is that you have the potential to do things in your application that might be considered a security vulnerability in another application, but it's all use case dependent. That's why it's important to know what is the business function of your application. An example here on the slide, if you're providing a world readable or world accessible public API, you probably need to open CORS or cross-origin resource sharing to the world so that other platform consumers can write clients that consume your API. However, if you're in a financial services institution, you probably want to restrict access to your API using CORS to a handful of explicitly named domains. Both of these are valid approaches, they're just different applications and use cases with different application layer security requirements. Another area that you retain responsibility for is authentication and authorization. These bullet points on the slide are OWASP's suggestions for managing authentication and authorization. First, by using available tooling. It's never a good idea to write your own authentication and authorization. It's an extremely complex and solved problem. Amazon offers Amazon Cognito, a managed service, which allows you to create user pools or federate user pools with existing identity providers and use that to provide authentication and authorization services for your application. There are also partners such as Auth0 that offer identity as a service. In the end, once your user is authenticated, you'll use AWS Identity and Access Management, or AWS IAM, to stitch all of these pieces of your application together. The next area that you retain responsibility for is data encryption and integrity. OWASP's recommendation is to identify and classify sensitive data, and that's especially true in a serverless model, where we're paying particularly close attention to the resources each function has access to. This has the added benefit of letting you know which functions you should focus your security review efforts on. If you have a function that has no read access to any sensitive data and no write access at all, you can probably spend less time, less effort scrutinizing that function when compared to one that is a core writing function of your business problem. Finally, OWASP recommends that you use infrastructure-provided services for managing private keys and encrypting data. Two services that AWS offers are mentioned here on this slide. AWS Key Management Service for managing, issuing, and revoking public and private keys, and AWS Secrets Manager, which allows you to encrypt and store secret configuration data for your application. It also provides an API for updating and rotating those secrets. The final category of functionality or responsibility that you retain in your serverless application is monitoring and logging. OWASP's recommendation here is to use the monitoring tools provided by the cloud service provider to identify and report unwanted behavior. Here on the slide, you see what we call the AWS Observability Triangle: CloudWatch Logs, X-Ray, and CloudWatch Metrics. each of which is built into AWS and provide a key service in securing your serverless applications. So what is some general guidance for taking these best practices and applying them to your application? Remember, we discussed the 3 dimensions of application risk: complexity, available resources, and dependencies. We talked about how writing a serverless application reduces your overall risk. Don't give these benefits away. Don't assign overly broad permissions. And what this means is don't use stars or asterisks in your IAM policies to grant world access to resources. Use specially crafted policies to grant access only to the specific resources that your function needs to perform its job, and deny access to all other resources. It may be tempting to use those wildcard patterns, but doing so returns you to the much expanded risk of the monolithic model. Another recommendation is not to use monolithic Lambda functions. What this means is don't try to pack your entire application into one function, because here again, you're going to have to include all of the dependencies that you had before, and you're going to have to grant that application access to all of the resources that it needs, read and write, across every function in your domain. Instead, package each Lambda function individually, with only the dependencies it requires, and grant it access only to the resources that it requires. A more subtle suggestion is not to use or not to grant CRUD or create, read, update, delete access when a combination of read and write will do. And here I'm specifically referring to the AWS Serverless Application Model policy templates, IAM activities or IAM roles that are created for you by AWS SAM that allow you to access resources. For both DynamoDB and S3, there are a combination of read, write, and other fuller access policies. If you need to read and write data to and from the same resource, I strongly suggest that you apply each of those policies independently. First, there are some differences between the combination of read and write and CRUD or full access. You may not be aware of those, and they may be introducing unnecessary risk to your application. Second, you may refactor your application over time. At a certain point in time, it may no longer need both read and write access, but you may leave those roles in place. In that case, you wouldn't notice that you had assigned unnecessary permissions to your function. Other general guidance is not to access data that you don't need. If you can make that call, if you can retrieve data from a data store by accessing another service or the parent service, maybe that's better from a risk management and security perspective than granting read permission to yet another resource. Because remember, you're growing the complexity and risk of your application along an axis. And finally, don't include unnecessary dependencies. This means that you include only what you need to perform the logic in each specific function. This may mean reworking your application to eliminate models or frameworks that you're used to working with. And that's okay to do that over time in an iterative replacement model. All of this is what you want to be your goal, not necessarily an overnight change. So when we take that general guidance, how do we apply it to specific services? In almost all cases, the answer is AWS IAM. But there's some differences or nuance with each service. For AWS Lambda, for example, there are 2 sides or 2 faces of permissions. First is the function policy. The function policy governs which services or principals can access or invoke your Lambda function. For example, actions on this S3 bucket can invoke the process object function in this account. Resource policies allow for cross-account access, which means that you can have shared storage or shared data stores that invoke specific processes in other accounts. And these policies are used for both synchronous and asynchronous invocations of your Lambda functions. The second portion of security with AWS Lambda is your execution role. And this defines what your function itself is permitted to do. What resources can it access? Can it read or write from or write to a specific DynamoDB table? Can it access objects or list objects in an S3 bucket? This is defined by a list of explicit API calls that it's allowed to invoke, and anything not listed is denied. So we spoke about the function policy as the first part. That's what can invoke your Lambda function. In this example, we have some code from an AWS SAM template. We see that the events property is defined to include an API event. What this does is this allows API Gateway to invoke your Lambda function. When you deploy a function this way using the serverless application model, all of this is created for you. A specific role and policy that allow that API Gateway endpoint to invoke only this Lambda function. On the execution role side, it looks like this. This is one of the managed policy templates that we discussed earlier, the DynamoDB write policy. In this case, our save to DynamoDB Lambda function has permission to write data to the user database table, but it does not have permission to read information from that table. These AWS SAM policy templates are included in AWS SAM. It's part of what you get when you build your applications with SAM. This helps you quickly deploy and deliver applications that don't have excessive permissions, using best practices to enable access to only the resources your functions need. AWS SAM is also open source, and if you visit the link on the slide, you'll see the repository where you can contribute your own policy templates for inclusion in SAM. Here we have an example of different types of policy templates. Policy templates can take no placeholder values. For example, the CloudWatch put metric policy that you see here on the slide just takes an empty object. That means that this function is allowed to put CloudWatch metrics without any specifier. You also have policies that require placeholder values. In this slide, the examples are the SQS poller policy, which allows your Lambda function to poll an SQS queue on a regular interval, and the DynamoDB write policy that we explored in a previous slide. The power of these policy templates is their simplicity. They allow these two lines on the left to become this entire correct and tightly scoped IAM policy that you see on the right. These policy templates are also applicable to other services in the AWS serverless application model, and I'd encourage you to explore them on your own at the links provided. Similarly, Amazon API Gateway is governed by IAM permissions. You can use roles, policies, and AWS credentials to grant access to an API. But you also have the concept of authorizers. You can write a custom Lambda function that performs business logic that you define to determine whether a request is permitted to be passed on to a resource. You can use Amazon Cognito user pools. We spoke about Amazon Cognito earlier. It's an ID provider as a service, and it determines whether a request is authenticated. If not, it rejects it before the request is passed on to the resource. And finally, resource policies on your API gateway itself can restrict access to API gateway based on inbound IP address, whether the request is coming from a particular VPC, whether it's coming from an AWS account ID, and other factors. Amazon DynamoDB is the most common data store for serverless applications, and it provides its own set of policies. We've reviewed the DynamoDB write policy in a previous slide. There's also the DynamoDB read policy that grants read-only access, the stream read policy, which allows you to attach Lambda functions and other resources to DynamoDB streams anytime an update occurs. As mentioned previously, we recommend you avoid the DynamoDB CRUD policy just so that you're always applying that fine-grained permission. There's a note here at the bottom of this slide about IAM condition DynamoDB leading keys. This is extremely fine-grained access to data in your DynamoDB table via an IAM policy. For example, you can grant access on an authenticated request only when the key to the item begins with the customer ID. You can use this, for example, to protect information on a per-user basis. Only I can read financial information from this database, and I can only read it when I'm logged in my account. You can also use it for data classification levels. You can check a user's classification level, and if they're authorized to access confidential information, you can grant access to information flagged with confidential in an item. Amazon S3 buckets are not public by default. Amazon S3 is our object storage, and it's typically used for your larger data in serverless applications. Again, access isn't public by default, and we strongly recommend you don't change this unless you know exactly why you're doing so. Again, AWS SAM policy templates will help you out a lot here. We have the S3 read policy for retrieving data, which requires a placeholder value of an S3 bucket. We have the S3 write policy for updating or writing data, which also requires the name of a bucket. And in general, we suggest you avoid using the S3 CRUD policy and the S3 full access policy wherever possible. Now, of course, there are API calls that are authorized by those two policies that aren't in the others, and if your application needs them, then that's a valid way to grant access to your application. Just be sure that you understand the ramifications or the implications on your application. Finally, you can use S3 access points to even further restrict access and control over your S3 buckets to your Lambda functions. Another commonly used service is Amazon Event Bridge, which serves as an event-driven backbone for your serverless application. It offers permissions for inbound and outbound operations, similar to the Lambda permissions that we discussed. Inbound operations determine what resources can place events or rules onto the bus. Outbound operations determine what your Event Bridge event bus can invoke. For example, can it initiate a step functions workflow, or can it invoke a Lambda function? Now, outbound permissions are determined by the receiving resource. So in this example on the slide, we see that we have an AWS step functions workflow that grants access to Amazon Event Bridge to start the named workflow. We don't define that with Event Bridge, whereas we define the first set of events inside Event Bridge. That is, what resources are allowed to put events onto the bus. Again, with AWS step functions, it's important to know that all of your data is encrypted at rest, and all of your data is encrypted in transit between step functions and the integrated services, because these services occur as TLS HTTP API calls. As with the other services, IAM governs step functions, executions, and invocations, but you need to know that if you're invoking synchronous or callback pattern tasks, you'll need additional permissions for Amazon Event Bridge. That's because step functions creates events and rules on your default event bus, and it needs permissions to do so, as we just discussed. So with this specific guidance, general guidance, and framework in mind, what are some of the trade-offs that we'll need to consider when architecting our serverless applications? First, remember that more so than with any other type of development, you aren't going to need it applies often with serverless. Typically, if you're going to extend your application, you're going to add another Lambda function. So don't grant access to resources you may need in the future, and don't bring in dependencies you may need in the future. Only include whatever you need today. There's also the single responsibility principle. Each function should only be doing one thing in terms of business language. It is updating a customer or retrieving orders from the last week. It's not doing all of these things inside of one place. Remember that complexity is one of our risk axes from our model. We want to reduce that complexity wherever possible by minimizing the number of paths through our code. But with apologies to Oliver Wendell Holmes Jr., whom I'm paraphrasing here, Simplicity before complexity is worthless. Simplicity beyond complexity is priceless. It doesn't do us any good to have a simple application if it can't adapt and incorporate our business rules. Business logic in the real world isn't simple. You have to ensure that you're incorporating all of that complexity into your function. This is why we recommend lifting any non-business oriented complexity out of your function and into something like step functions workflows where it can be managed independently. And this includes error handling and retries. There are also some situations where you cannot avoid different types of complexity, such as governance and compliance requirements like PCI or HIPAA. You may also operate under a high-risk threat model where you have additional complexity that must be baked into each Lambda function. Note that these are exceptions, and it's where the real-world implementation of these criteria has to bend to adapt to what it is that you as a customer built. Still, when you're making those trade-offs, try and do the following. Only handle the happy path inside your Lambda function. Now, some people might look at this and see laziness, but in fact, it's efficiency. As I mentioned before, step functions workflows have robust retry and error handling catchers built in. Make use of those so that your function is easier to maintain and easier to get right the first time. Ruthlessly decompose your business logic. If you have business logic diagrams or process diagrams, use those as a guidance for where you should break apart your workflows. Make sure that there's nothing left that you can't pull out into a repeating function or process. And finally, wherever possible, eliminate code with service integrations. This means using service integrations like the DynamoDB put item to store data directly from your step functions workflow into a DynamoDB table without ever invoking a Lambda function. This means that you have no code to maintain, no code to go stale, and no vulnerabilities to be introduced over the course of time, because all of these service integrations are being managed for you by AWS. A quick note on compliance, since we've already spoken about it as one of our irreducible complexities. All of the services that we've discussed today are compliance ready for each of these frameworks. Note that, as always, doesn't guarantee compliance. It means that the conditions are in place for you to build applications that are compliant with these frameworks. For additional information on compliance on AWS, please see the link given here on this slide. So finally, in conclusion, serverless application security is balanced toward the application, not the infrastructure. Most of your time and effort should be on your business logic, not on underlying pieces like networks, operating system patches, and other undifferentiated heavy lifting. Serverless application security is also more fine-grained. It allows you to strip out unnecessary resources and dependencies from each function, reducing your overall risk. But, as we mentioned early on, serverless application security is not to be taken for granted. It is still work, and it still needs to be done by you, the customer. I hope you've learned a lot from today's presentation, but remember, this was only a start. AWS provides a number of resources to help you build secure applications, and they're available here on this slide. Thank you for joining us today. I hope that you've learned how to secure your serverless applications, and I look forward to your questions and seeing what you built.